Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to start a new topic, chapter number 3, hypothesis testing. Right. So as an introduction, so statistics, as we know, is divided into two types of statistics. We have descriptive statistics and inferential statistics. So our main objective in this chapter, in this syllabus, is to focus more on inferential statistics. So last chapter we already looked at estimation, right? We already know how to do what is a point estimate and how to find estimator using method of moment and maximum likelihood estimator. And we also know the good properties, or the properties of good estimator, right? Which is unbiased, sufficient, consistent, and efficient. We also learn how to find a minimum variance unbiased estimator. And we also look at interval estimation, right, for mean, single mean, two mean, single variance, two variance, right? So in this chapter, we are looking into hypothesis testing. So in hypothesis testing, still under inferential statistics, right? So the basic logic of hypothesis testing is to prove or disapprove a research question, right? So we want to approve or disapprove a research question. So this is the logic of hypothesis testing. So we want to make a correct decision, right, based on statistical principle, and we also allow 1 to 5% margin of error for us to make a incorrect decision, right? Where in hypothesis testing, we are not 100% sure that our decision is correct. We are reserve 1% or 5% for making an error lah. Right, same goes to in estimation. We still reserve 5% error, right? For example, last chapter you already learned how to find 95% confident interval for a population mean. So we are 95% confident, and another 5% is reserved for incorrect decision, right? So the same concept we still apply in hypothesis testing. So the definition of statistical hypothesis is assertion or conjecture about the distribution of one or more random variable. So if a statistical hypothesis completely specify the distribution, so it is known as simple hypothesis, right? If not, is referred as a composite hypothesis. So if the hypothesis have specified the distribution, right, so it is called as a simple hypothesis. If not, then it is called as a composite hypothesis, right? So now let's look at the basic term. So we already know simple hypothesis and composite hypothesis. So for simple hypothesis is a functional form, right, underlying distribution, and the value of all parameter, right? So means that it has all the value of the parameter, and it will represent from some distribution, right? For example, this is the symbol for null hypothesis. For example, if we have variance of height is equal to 4, and the mean of the hypothesis is mean is equal to 62. So we already know specifically variance equal to 4 and the hypothesis is 62. So this is what we call as a simple, right? So in general, null hypothesis H null, H naught, theta equal to theta naught, means theta naught here is the value. Is specified is a specific value for the parameter theta, right? So if to differentiate between composite hypothesis and simple hypothesis, it has a specified value. For example, sigma squared equal to 4 and mean equal to 62. So in other term, which is composite hypothesis, it's not a simple hypothesis, which is it does not have a specified value for the parameter. Mean, for example, if you look at this one, H null mu is more than 62, where the variance equal to 4. So we already know the specified value for variance, but we really don't know the value for mean, right? The value of mean is more than 62. It could be 63, 64, and so on, right? It's not really specified value, right? So kita tak tahu value yang exact value for the null hypothesis, right? For example, let's say we have a null hypothesis mean equal to 62 and the variance is less than 4. We already know the mean is 62, but the variance is unknown, right? We don't know the specified value of variance. So variance could be 2, could be 3, could be 1, right? It's not specified value. So when we have this situation, so it is called as a composite hypothesis, right? So far, do you have any question? Can you understand the difference between simple and composite hypothesis? Because this is very important. This is the basis of the hypothesis testing. If you fail to understand basic simple and composite hypothesis, then we cannot move on to the next level. So can I have a comment on chat room? Right, sure. So you understand, right? I hope you understand. So I repeat again, just a repeat. For simple hypothesis, the value of null hypothesis or alternate hypothesis, it should have specified value, right? Either in mean or variance, right? For composite hypothesis, it does not have a specified value, or both mean and variance, or either one. For example, this one, mean is more than 62, right? So it does not have a specified value, where the variance is having a specified value. This is a composite hypothesis. And another one is mean is having a specified value, but the variance is not specified. So this is also a composite hypothesis, right? So now this is one of the example of composite hypothesis, when H null mean equal more than 7,000, right? This is not specified value, so this is automatically composite hypothesis. But the second example, we have lambda is equal to 2, right? For the null hypothesis, lambda is equal to 2, right? So initially we know that this is a simple hypothesis, but when we look at the alternative hypothesis, the lambda is more than 2. So this is not a specified value. So this is a composite hypothesis. So both of all of these are composite hypothesis. And number 3, alpha less than or equal to 7, alpha more than 7. So this is a composite hypothesis, clearly, right? So another term that you need to understand is null hypothesis and alternative or alternate hypothesis. Null hypothesis, the symbol for null hypothesis is H naught. So this is a symbol for null hypothesis. Is a statistical hypothesis that states there is no difference between a parameter or specified value. So this is the first argument, our first argument. So this is just a letter that presume innocent until proven guilty, right? So this is going to be accepted unless we have the data show otherwise, right? Show the result in otherwise. right? So the alternate hypothesis, the symbol for alternate hypothesis, HA or H1. So sometimes in old books or some books will use HA, some book will use H1. So it is a statistical hypothesis state that is specific difference between a parameter or specific value. In other words, the hypothesis to be accepted in case null hypothesis is rejected. So null hypothesis and alternate hypothesis should be together under hypothesis statement. In hypothesis statement, it should contain null hypothesis mean equal to 2, for example, right? Let's say I put this one, mean equal to mu naught, and alternate hypothesis mu is not equal to mu naught. So this is hypothesis statement. So in hypothesis statement, it should contain null hypothesis and alternate hypothesis, right? So far, any question? Do you understand null hypothesis and alternate hypothesis? So this is very important. There are 4 terms that you need to understand. First is simple hypothesis, composite hypothesis, null hypothesis, and alternate hypothesis. Before we can go on, you need to understand these 4 terms. Can you comment? Any questions so far? Right, good. Right, so the element in statistical tests or hypothesis, we have 4 main elements. The first element is null hypothesis. Second element is alternate hypothesis. So first element and second element lies under one big element, which is hypothesis statement. And the third element is test statistics. So we're going to use either Z test, T distribution, chi distribution, and F distribution. So these 4 distribution we already looked into chapter number 1 and chapter number 2. We already learned it thoroughly, right? So once we decide which test to use, and we're going to set for a critical region or rejection region. So rejection region, for example, let's say we have a normal distribution, right? So if we are measuring for two-tail distribution, let's say this is the mean. Oops. So this is a normal distribution, right? So let's say this is the mean, and we are measuring two-tail. So 1 minus alpha is in between, and this is going to be your alpha. This is going to be your alpha. So alpha here is the rejection region. This is the rejection region. So this is going to be acceptance region, right? So now, in conducting a hypothesis testing, right, this is the element, right? We have 4 elements, but in conducting hypothesis testing, or we're going to construct a significant test, right? The first step is we need to write down our hypothesis testing. So this is the first step. You should have your hypothesis testing. Either null, you should write down null hypothesis mean equal to 2. Alternative hypothesis is mean more than 2, for example, right? And then we should specify our statistical test. Either we want to use a Z distribution, T distribution for single mean, Z distribution or T distribution for 2 mean. This is for 1 mean, and chi-squared distribution or F distribution for sigma squared, right? So this one, statistical test, we already we have looked into chapter number 2 thoroughly. We already learned it, right? And then step number 3, we need to identify our critical value and the rejection region, right? Critical value, we need to understand what is a type 1 error. Type 1 error normally is alpha, and type 2 error is our beta, right? We need to know the critical value, and we need to identify our rejection region. Right, once you identify the rejection region, we need to base on the statistical test, and we're making a decision. Right, we're making a decision based on the decision rule. So decision rule is based on rejection region and statistical test. Once we make a decision, then we're making a conclusion. You see, this is a step number 5. Right, so this is a step in conducting hypothesis testing. We have 5 steps. First step is hypothesis testing, hypothesis statement, statistical test, critical value, decision, and conclusion. Right. So step number 1, hypothesis testing or hypothesis statement. So we need to specify null hypothesis and alternate hypothesis. So again, the definition of null hypothesis is statistical hypothesis that there are no difference between a parameter and a specific value. Alternative hypothesis, the hypothesis that state a specific difference between parameter and specific value. Right. So the test type of hypothesis. So we have again, I ulang benda yang sama saja. We have simple hypothesis. The value of parameter in HA is given by specific value. So means that these two null hypothesis and alternative hypothesis have specific value. Means null hypothesis we have phi is equal to 4, alternative hypothesis phi is equal to 5. So in composite hypothesis, the value of null alternate hypothesis is not given as a specific value. Right? For example, for null hypothesis phi is equal to 2, alternative hypothesis phi is not equal to 5. Right? So it can be many number. Right? So same goes to phi is more than 2, less than 3, right? So it can be either null hypothesis or alternate hypothesis. Right, now we look at the statistical test step number 2. Use the data to obtain from a sample to make a decision whether or not null hypothesis should be rejected. So this is the crucial step. So we're going to use the data, and we're going to make a decision based on statistical tests, either Z distribution, T distribution, or chi-square or F distribution, right? To make a decision whether we're going to accept null hypothesis or reject null hypothesis, right? So statistical test is a numerical value obtained from a statistical test lah. So the step number 3 is a critical value. Critical value is separate the critical region from the non-critical region, right? For example, tadi ada tunjuk tadi kan. This is the normal distribution. We separate critical region, rejection region and acceptance region. So this is a rejection region. This is acceptance region. So this value is critical value, right? So this is also a critical value, right? So it separate between the rejection region and acceptance region, right? So let's look at this one. I satu lagi benda yang sama saja. I just ulang benda yang sama. This is mu. Let's say this is a normal distribution. We have a rejection region. Let me put clearly. This is a rejection region. This is acceptance region. Right? And this is also a rejection region. So the line here, which is separate between acceptance region and rejection region, this is what we call as critical value. This is critical value, right? So area on the left hand side here and area on the right hand side here is when we reject null hypothesis. When we reject null hypothesis, so the value of test statistic should lies in rejection region. If the value of test statistics lies in acceptance region, we're going to accept null hypothesis, right? So this is the condition where we have two-sided, right? So the same concept will apply for a single-sided, right? So we're going to accept null hypothesis if the value of test statistics lies between acceptance region, when the value of test statistics lies on a rejection region. So we're going to reject null hypothesis. So this is very simple, right? So now look at this one. So we have a hypothesis statement and critical value. So this is just a guidance. So let's say the sign in null hypothesis is either equal or more than, right? So it can be, let's say, this one, let's say null hypothesis mu equal to 2, or null hypothesis mu is more than 2, right? And the sign in acceptance region, the sign in alternate hypothesis, let's say mu is less than 2. So this is region is left tail, right? So we're going to sketch the area on the left, right? So how we know is from left, it based on the alternative hypothesis. If the alternative hypothesis is less than, so it should be skewed to the rejection region should be on the left tail, right? So if the alternative hypothesis is more than, so it should be on the right tail, right? So rejection region should be on the right tail. If the null alternative hypothesis is inequality, it should be on both tail. So it's a both side distribution, two-side distribution. So this is rejection region. So this is rejection region for both tail, and this is the rejection region on the right hand side. This is the rejection region on the left tail, right? So basically, in order to know where is the rejection region, either left or right or both, it depends on alternative hypothesis, right? So any questions so far? Ada soalan? Soalan ada? No question? Right? Ya, soalan. Apa soalannya? Izzati ada soalan ke? Null hypothesis, can we choose either equal or more than? No. Null hypothesis is based on the statement, right? So either the statement is equal or more than or less than, right? So we don't care on the null hypothesis. We only care on alternative hypothesis to decide where is the rejection region. So either on the left hand side or right hand side or both this side. So if the alternative hypothesis is less than, so the rejection region should be on the left hand side. If the alternative hypothesis is more than, so rejection region should be on the right hand side. If the alternative hypothesis is not equal, so it should be on both sides. Right? Jawab soalan tak? Alright, okay, good. So now we move to the next slide, which is type of error, right? So there are 4 possible outcomes in our decision in a statistical test, which is a hypothesis testing. So either we make a correct decision, right, or we make a error, right? So let's say the state of nature, the null hypothesis is true. When the null hypothesis is true, but we reject null hypothesis, this is our decision. This is our decision. When the null hypothesis is true, we reject null hypothesis. This is considered as error. So what type of error? This is type 1 error. Type 1 error is alpha. When the null hypothesis is false and we reject null hypothesis, this is we are making a correct decision. Right? We are making a right decision. When the null hypothesis is true and we accept null hypothesis, we are also making a correct decision. When the null hypothesis is false, we accept null hypothesis. We are making a error. We are making a mistake. So this is what we call as type 2 error. Type 2 error, the symbol is beta. Right? Remember, in previous chapter, we also reserve 5% or some percent in making a wrong decision. Right? We are not 100% sure. Right? When we are predicting or estimating the mean of population mean or population variance, we are not making 100% confidence. We are not making 100% conclusion. Right? We are making 95% confidence. We are making 99% confidence. Right? We are reserving 1% or 5% to making for our decision to be wrong decision. Right? So this is possible state of nature, possible outcome with 2 type of error, right? So type 1 error is the probability of rejecting null hypothesis when the null hypothesis is true. So we are rejecting null hypothesis when the null hypothesis is true. So this is what we call as a probability of type 1 error, right? And the type 1 error is denoted as alpha, right? So it's also called a level of significance, right? It's also called as a level of significance, which is also the symbol is alpha, right? And the type 2 error is when we accept null hypothesis when null hypothesis is false, right? So this is type 2 error. Type 2 error is beta. The symbol for type 2 error is beta. The beta is equal to the probability of accepting null hypothesis when alternate hypothesis is true, or you can put like this: we are accept null hypothesis, right, when null hypothesis is false, right? It's the same concept lah, right? So basically we're going to look at type 1 error and type 2 error very thoroughly on the next topic, right? So in this topic today we're going to look at very simple hypothesis, right? So how to solve the problem using statistical tests, right? So tadi kita tengok step number 3. Step number 4 is making a decision. So we need to make a decision based on the decision rule, right? So whether we're going to accept null hypothesis or reject null hypothesis, right? And that last step is making a conclusion. So if the value of test statistic lies in critical value, and then we reject null hypothesis, critical value or rejection region. right? So if the value of test statistic does not lies in rejection region, so we accept null hypothesis. So this is the conclusion that we're going to make in statistical hypothesis, right? So testing a hypothesis, right? So in step number 3 ni kan, right? We are step number 2, we are looking into statistical tests, right? In statistical tests, let's say recall our knowledge on previous topic. Let's say we have Z distribution is x bar minus mu divided by sigma over square root of n, right? So another one is we have Z is equal to x bar minus mu divided by s over square root of n. So this is when the population variance are known, right? Population variance known, right? And this is when the population variance unknown, and provided n is more than 30, right? This one we don't care whether n is less than 30 or more than 30, as long as the population variance is known, right? And number 2, we have T distribution, x bar minus mu divided by s over square root of n, and this is where the condition population variance are known and is less than 30, right? Less than 30. This is more than or equal to 30, right? So this is for a small sample. And what else we learned on the previous topic? Step number 3, we have a chi-square distribution. Chi-square distribution n minus 1 s square divided by sigma squared. So this is to test single population variance, one population variance, right? And number 4, we have F distribution, right, which is s1 squared divided by s2 squared. This is when to test two population variance, right? So since we are looking into two population variance, let's say we have two population mean, right? Two population mean, let's say number 5 T, let's say look at Z dulu, right? Tulis kat bawah lah. So we have Z number 5. Z is equal to x bar 1 minus x bar 2 minus this is mu 1 minus mu 2 divided by, and then we have unequal variance n1 plus n2, and this is a square root, right? So this is when we want to test the difference of two population mean, and provided that population variance is known, right? The population variance is known, and then we want to test two population mean. We can use Z distribution with different two means, right? This is a two population variance is unknown, right? So it doesn't care whether the sample size is less than 30 or more than 30. We don't care, right? As long as the population variance is known, right? And then we want to test the difference of two population mean, we can use that distribution. And number 6, we have T distribution, right? This is the same procedure, right? Minus mu1 minus mu2, right? And then we divide by this is a pool standard deviation 1 divided by n1 plus 1 divided by n2. So this is when we want to test the difference of two population mean, and provided two population variance are unknown. Another one is the population variance are assumed to be equal population variance. So this is the condition, and provided that n is less than 30. So this is a very small sample, right? When we have n is more than 30, we can use that distribution as well, right? Okay. Any questions so far? Before we go for example and so on. Boleh faham? So we're having a test statistic, right? Yang we need to remember, right? So either Z distribution, T distribution, K distribution, F distribution, right? So now we look at the test sample hypothesis. So basically, I already explained on the formula. The same thing. We test concerning mean. We are testing concerning variance. We are testing the difference between mean and variance. Right. So let's say we look at test concerning mean. Right. So for this example, we have a single or one tail test. This is case number 1. We have one tail test. The hypothesis statement for one tail test, for example, let's say we have null hypothesis mean equal to mu naught. Alternative hypothesis mean is less than mu naught. Or we have another one is null hypothesis mean is equal to mu naught. Alternative hypothesis mean is more than mu naught. So this is the example of one tail test, right? The test statistics, we can use Z distribution, right? Y bar minus mu naught divided by sigma over square root of n. So this is Z. This value we will mention as Z calculated, right? Or if you use T distribution, we're going to mention T calculated. Or chi-square distribution, chi-squared calculated. F distribution, F calculated. Right? So for the critical value for the first part here should be on the left hand side. Right? So this is the rejection region. Right? This is going to be your alpha. This is negative Z alpha. Right? And this is 0. For let's say you are already convert into a standard normal distribution. For this example, since the alternative hypothesis is more than, so it should be on the right hand side. So this is 0. This is a rejection region, right, which is your alpha, and this is Z alpha, right? So this is the critical value. Decision is, let's say for this one, if Z calculated is less than negative Z alpha, right, which is Z calculated is the value of Z calculated lies somewhere here, right? So null hypothesis is rejected, right? If in this situation, if Z calculated or T calculated or chi-squared calculated is more than Z alpha, so null hypothesis is rejected. So this is the basic concept of hypothesis, right? So then we make a conclusion. The test statistic lies in critical region. Conclude based on a accepted hypothesis. We're going to conclude based on accepted hypothesis. So now we look at the next case where we have case number 2 is two-tail test. So the two-tail test hypothesis statement should be like this. Null hypothesis mu is equal to mu naught. Alternative hypothesis mu is not equal to mu naught. So we automatically know that this is a two-tail test because the alternative hypothesis is not equal, right? So this one should be either both side or either right hand side or left hand side. So this is going to be your rejection region, and this is going to be your rejection region. This is acceptance region. So for this example, let's say we use Z distribution, right? Let's say for example we use Z distribution. This is going to be Z calculated, right? So Z calculated should be y minus mu divided by sigma over square root of n, right? So this value here should be Z alpha divided by 2. This is Z alpha divided by 2, right? This is a difference between the one-sided test. For one-sided test, we don't need to divide both sides. So this is going to be this whole alpha. So that's why Z alpha, negative Z alpha. This is Z alpha, right? For two-sided test, the rejection region in both sides, right? So we are dividing alpha into 2, right? Because we're going to divide these two area equally, right? So decision rule, if Z calculated is less than negative Z alpha over 2, or Z calculated is more than Z alpha divided by 2, and then we reject null hypothesis, right? So we're going to conclude based on acceptance hypothesis, right? So this is going to be alpha divided by 2. So you need to remember this one and make sure you understand the difference between one-sided test and two-sided test, right? So far, before we start with our question example, do you have any question? Question? No question? Right. So now we look at example number 1. So we try to construct the hypothesis testing or statistical test, right? So remember we have 5 steps, right? 5 steps in conducting statistical tests. First step is hypothesis statement. Second step is test statistic. Third step is critical value, decision, and conclusion, right? Suppose that it is known from the experience that the standard deviation of weight of 8 ounce package of cookie is 0.16. To check whether its production is under control on given day, so that is to check whether the true average weight of the package is 8 ounce, right? So we need to make sure the mean of the mean of weight should be 8 ounce. So the employees select 25 package and find the mean of the package is 9.091 ounce, which is the sample mean is not equal to 8 ounce, right? Since the bakery stand to lose money when the mean is less than 8 ounce, right? So when the average weight is less than 8, so the bakery will lose money. So we need to test the null hypothesis mean equal to 8 against the alternative hypothesis mean is not equal to 8, and we make 0.01 level of significance. So remember, level of significance is alpha, right? So now, first step, let me use this one. This is your alpha. So first step, hypothesis statement. So your hypothesis statement, null hypothesis mean equal to 8. Alternative hypothesis mean is not equal to 8. So your alpha is equal to 0.08 01, right? So second step is test statistic, right? So based on this one, you have n equal to 25, and you know the population variance. Population standard deviation is 0.16. You already know the population variance, and mean is equal to 8. The sample mean is equal to 9.091. So this is your information from this statement, right? From this, we can decide to use Z distribution lah, because the population variance is known. So Z distribution, x bar minus mu naught divided by sigma over square root of n. So which is equal to 9. Sorry, I salah tulis this one. This one should be 8.09. This is 8.0991. Right, baru nampak logik sikit lah. Kalau letak dia dah lari banyak sangat kan. So this is 8.091. So minus the null hypothesis. This is mu naught, right? This is mu naught minus 8 divided by sigma is 0.16 over square root of 25. So this one should be equal to 2.84. Right? Can you calculate for me? Is it equal to 2.84? 8.091 minus 8. Yep. Okay, so the next thing is the next step. This is step number 1. This is step number 2. Step number 3. We need to determine the critical value. The critical value is, so we know that this one we have two-sided distribution. So always draw a shape of normal distribution, right? So this is the mean, right, equal to 0, right? This is your z, negative z alpha divided by 2. This is z alpha divided by 2. So our alpha is equal to 0.01. 0.01 divided by 2 is 0.005, right? So we want to find z 0.005, and this is z 0.005. So z 0.005 is equal to negative 2.575. This is 2.575, right? So this is a critical value. Next, we need to make a decision. Step number 4, decision. So our decision rule, if a z calculated, this is a z calculated, lies more than z alpha divided by 2, we reject null hypothesis. If the z calculated is less than negative z alpha divided by 2, we reject null hypothesis. So we need to write down the decision rule. If z calculated is less than negative z alpha divided by 2, which is equal to negative 2.575. Null hypothesis is rejected. So if z calculated is more than z alpha divided by 2, which is 2.575, we're going to reject null hypothesis. Right? So number 5, our conclusion, since z calculated is equal to 2.84, which more than z alpha divided by 2, which is 2.575, we're going to reject H null is rejected. Right? So since we reject null hypothesis, we can say that the mean of weight is not equal to 8 ounce. Right? So this is how we construct a hypothesis testing. So basically we have 5 steps. So, are you okay? Right. So, for example number 2, I want you to write down the question and try to answer the question. Right? And give me your decision. Either accept the decision rule, decision, or reject. Either you accept the null hypothesis or reject null hypothesis. Right. So macam mana nak jawab ni? Suppose that 100 tires made by a certain manufacturer last on average 21,819 miles with a standard deviation of 1,295. So test the null hypothesis, mean mu is equal to 22,000 miles against the alternative hypothesis, mu is less than 22,000 with at 5% level of significance. So this one, null hypothesis should be apa? Can you comment? Null hypothesis sama dengan apa? Can you speak up? Null hypothesis sama dengan berapa ni? Hey, come on. Null hypothesis should be mu equal to 22,000. Alternative hypothesis, HA, mu is less than 22,000. So alpha is equal to 0.05. Our test statistic. So since we have n is equal to 100 and we have standard deviation is equal to 1295, right? 1295. So this is a standard deviation for 100 tires. Right, so this is S equal to 1295 and the average for 100 tires is 21,819, n equal to 100. So since we don't really know the population variance, so we're going but the sample size is more than 30, we're going to use Z distribution, x bar minus mu naught divided by S over square root of n. So this one should be 21,819 minus 22,000 divided by the square root of sigma s square is 1295 over square root of 100. So this one should be equal to negative 1.4. Right? So negative 1.4 And next step is we need to find the critical value. The critical value for this one is one-sided test. This is only on the left hand side. So this is the rejection area, and this is acceptance area, right? This is negative z alpha. Alpha is 0.05, should be negative 1.645, right? So our decision rule, if z calculated is less than negative 1.645, null hypothesis is rejected. So since z calculated is more than negative 1.645, which is equal to negative 1.4, null hypothesis is accepted, right? So conclusion. So what is the conclusion? So there are no real evidence that the tire are not good as assumed under the null hypothesis, right? So that is how we interpret or conclude the hypothesis statement, right? So basically, we already learned all these statistical tests, right, in previous chapter. In fact, in chapter number 1 and chapter number 2, we already learned these statistical tests, very thorough, right? So you should be able to apply when you have the situation, right? This is a situation when the population variance unknown n is equal to 100, right? And example number 3, when you have a small sample, right? Small sample, and the population variance are unknown, right? So what test you're going to use? The step of conducting statistical tests are same. First is the hypothesis statement, test statistic, critical value, decision, and conclusion, right? So I have a lot of example, right? So this example, until example number 10 is we are covering T distribution and Z distribution for single mean and different of two means, right? So I'm not going to do all example for you, right? I'm going to leave it for you for as a homework. You should do by yourself. Try to figure out how to answer the question. But basically, before I leave it for you, I am very sure you already know how to choose the test statistics, right? Because we already discussed this very thorough in chapter number 1 and chapter number 2, right? And in this chapter, I already introduced to you how to conduct a significant test or hypothesis testing. We should have a first step, hypothesis statement, test statistics, critical value, decision, and conclusion, right? So this is the basic step. So now, just to go through, you can speak up, please speak up, right? I nak you cakap, right? Jangan tulis I nak cepat, nak habiskan cepat, right? So make sure you cakap. I just nak tanya you simple saja. So in example number 3, right, we have the mean of braking strength is 185, and then we select 1, 2, 3, 4, 5 piece of ribbon coil. So this is the value, right? So null hypothesis, mean equal to mu is equal to 185. The alternative hypothesis, mu is less than 185. So this is a single or one-sided. So dia sebelah mana? Kanan ke kiri? Can you speak up? This one kanan ke kiri?
Kiri.
Kiri, right? So this is a left tail. So our alpha is 0.05,
Series ya.
right? So test statistik yang kita akan guna ni apa? This is T test or Z test? Right, so n is equal to 5, very small, and the population variance unknown. So, apa lagi you nak? So, kita pakai test apa ni? T or Z distribution? Ya, tolong cakap, speak up. I nak habiskan cepat. So, kita nak go through one by one, sikit saja. Briefly, sebelum I leave it for you to answer the question. So this one should be T distribution lah, right? So now look at example number 4. Example number 4, we have the null hypothesis is apa ni? So kita baca sikit. Dekat sini dia kata, Vice President in charge of sale for a large corporation claims that salespeople are averaging no more than 15 sales contact per week. Means that apa? Dia sebelah kanan apa? Dia no more. Dia claim this is the claim of manager. Mean is less than 15, no more than 15, less than or equal to 15. So null hypothesis should be equal to 15. So this is a hypothesis statement. And then they take 36 salespeople. The sample is 36, right? And then the population variance. Dia kata the mean and variance of 36 measurement are 17 and 9 respectively. So we don't know the population variance, right? But the sample size is big, so we can use Z distribution, right? For example number 5, so what is the alternative hypothesis, null hypothesis? Kalau kita tengok dekat sini, test hypothesis average output is 130. So null hypothesis mean equal to 130. Alternative hypothesis is less than 130. So mean is less than 130. Right? So the alpha is equal to 0.05. So we have 40 sample. Right? And the mean for 40 sample is 128 and standard deviation is 2.1. So this is Z distribution. Right, so very, very simple. Right, so you just need to understand, identify what is the value for the test statistic we're going to use. Right, so this one same for example number 7. Example number 7, we have two population, right? Two population, soil type 1, soil type 2, and the sample size is more than 30. More than 30 or equal to 30. Right? So, since the sample size is more than 30 or equal to 30, so we are automatically going to use Z distribution. Right? Tak payah fikir banyak. Right? So, example number 8. The alternative hypothesis. Yeah. Because we don't, because the sample size is more than 30, right? So when the population variance is known or unknown, right? Sorry, when the population variance is unknown, right? The sample size is more than 30, we use Z distribution. When the sample size is less than 30, use T distribution. That's a very simple rule. Right, for example number 8, right, so here we have 18 observation, right? The null hypothesis, kalau kita tengok dekat sini, what is the null hypothesis? Dia tak bagi dalam statement ni, so dia tulis kat bawah ni, Is there sufficient evidence to claim that average gallon gas tax is less than 45 cents? So mu equal to 45. Null alternative hypothesis mu is less than 45, right? So alpha is 0. Let's assume alpha is 0.05, right? Kita ambil 0.05. Right. Kalau dia tak bagi dalam question, means kita assume 0.05. Right. So now population variance. So dia kata but the state local tax vary from 7.5 to 32.1 and equal. So they're not giving us the value of population variance. So we only know the sample standard deviation and mean from this data, right? We need to calculate the mean as the standard deviation. So when the population variance is unknown, we use T distribution. Very simple. For example number 9, sama juga. So kita tak tahu the population variance, but the sample size is less than 30, right? So population variance unknown, use T distribution with pool standard deviation, right? But this one kita kena ingat balik, dalam chapter number 2 we already look at how to test two distribution have equal variance, right? So we need to test for the variance equality, right? Use our knowledge on chapter number 2, and then we construct a 95% hypothesis testing, right? Using T distribution, right? Again, for example number 10, benda yang sama juga, right? So the population variance unknown, right? So this one should be apa? Dia punya hypothesis testing macam mana? The hypothesis testing, let's say, tadi kita tengok yang sebelum-sebelum ni for single mean kan? This one for hypothesis testing for this one, mu1 or mu for method 1 equal to mu for method number 2. Right? Because we want to know whether the different mean score population associate the two teaching methods. So we want to know whether these two methods are equal or not equal. Right? HA, mu1 not equal to mu2. Or we can say in otherwise, we can put in another form, null hypothesis mu1 minus mu2 equal to 0. Alternative hypothesis mu1 minus mu2 not equal to 0. Benda yang sama lah. Right? For this one, example number 10 ni, nak dia kata apa? Test the hypothesis that mean amount DDT found in juveniles and nestling do not differ versus alternative that juvenile have greater mean. So juvenile, let's say null hypothesis mu j equal to mu n, j for juvenile and nesting. So alternative hypothesis mu j is more than mu n, right? Ataupun kita boleh letak satu lagi macam ni, null hypothesis mu j, ataupun lagi senang I suka letak mu1 and mu2. Let's say this is 1 and this is 2, right? Mu1 minus mu2 equal to 0, dan HA mu1 minus mu2 less than 0, right? So we just choose our statistical test, right? So for variance, same condition, right? Same condition. When you have a single variance, use chi-square distribution. When you have two-sided distribution, so you need to adjust the critical value, right, for single and double sided, right? Same goes to two population variance, right? For two population variance, when you have a single one-sided test, so this is the formula of critical value. So this is a formula for two-sided test. So you can use either this one or this one, right? It's the same formula. So because we already discussed this in thoroughly on chapter number 2, right? So now untuk variance ni nanti I bagi dekat you tomorrow lah, tomorrow kita buat. But for today, 10 example for you to do as your homework. I think that is going to be sufficient for you, right? Enough. Sebelum kita masuk kelas esok, right? Esok kita akan continue lagi on variance and single variance and double two variance, right? And of course tomorrow kita akan discuss balik example 1 until example number 10, right? So I will leave it for you. So kalau you boleh buat sampai hujung sekali pun bagus juga, sampai 16 example, right? So we will discuss tomorrow example 1, example number berapa kita berhenti, number 3 sampai 16 tomorrow. But provided you need to do all the example as your homework lah. Make sure you do it by today, right? So senang saja, tak susah sangat pun. We just buat saja. Right, sebab in this example number 3 until example number 16 dia tak menguji binda sangat, right? So next class, maybe after Raya, we will continue on type 1 error and type 2 error, and the last topic, very big topic, which is Neyman person lemma, to find the best critical region, right? So far ada soalan tak? Right, so I will leave it for you. Example number 3 until example number 16. Do as your homework, right? I think that's all. Thank you very much, and Assalamualaikum.